6,000 worlds. That's how many planets we've confirmed beyond our solar system. 6,000 distant spheres scattered across the spiral arms of the Milky Way, each one a world unto itself. Some orbit close to their stars, locked in perpetual daylight. Others drift through darkness at the frozen edges of their systems. A few hang in that narrow band we call the habitable zone, where temperatures allow liquid water to pool on a surface, where the chemistry of life as we know it becomes possible. We found them by watching stars flicker. When a planet crosses in front of its star from our perspective, the light dims, just slightly, a fraction of a percent. But our instruments are sensitive enough to catch that momentary shadow. The Kepler Space Telescope stared at a single patch of sky for years, monitoring over 100,000 stars simultaneously, counting the dips in brightness, measuring the rhythm of unseen orbits. Every repeated dimming suggested another world. Every pattern revealed a planet's size, its distance from its star, the length of its year. Other worlds announce themselves through gravity. As a planet orbits, it tugs on its parent star, causing the star to wobble ever so slightly. That wobble shows up in the star's light spectrum, a subtle shift toward red and blue as the star moves toward us and away. We've learned to read these tiny variations. They tell us not just that a planet exists, but how massive it is, how quickly it moves, whether it travels alone or in the company of others. The more we looked, the more we found. Rocky worlds barely larger than Earth, gas giants that dwarf Jupiter, super-Earths with no equivalent in our own system, planets orbiting binary stars, their skies lit by two suns, worlds around ancient red dwarfs that will burn for trillions of years. Statistical analysis of the discoveries suggests there are more planets than stars in our galaxy. Hundreds of billions of them, perhaps more. Among those thousands we've confirmed, dozens sit in habitable zones. They orbit at distances where surface temperatures could allow liquid water. They're rocky, not gaseous. They're the right size to hold an atmosphere. On paper, they resemble Earth in the ways that matter most for biology. We found them around stars like our sun and around cooler, dimmer stars that are far more common. We found them in clusters and scattered through the spiral arms. The galaxy, it turns out, manufactures potentially habitable worlds with remarkable efficiency. The ingredients for life seem ordinary: carbon, hydrogen, oxygen, nitrogen. These elements form in the cores of dying stars and scatter through space when those stars explode. Every molecular cloud, every nebula where new stars ignite, carries the raw materials. Organic molecules, complex carbon compounds, have been detected in comets, in asteroids, in the space between stars. Amino acids form in laboratory simulations of early planetary atmospheres. The chemical pathways that lead toward biology don't appear to require rare or exotic conditions. Water is everywhere. Locked in ice on moons around Jupiter and Saturn, flowing beneath the surface of Mars billions of years ago, delivered to young planets by countless impacts. Where we find the right temperature and pressure, water exists in all three phases, cycling between ice and liquid and vapor, creating the dynamic environments where chemistry becomes complex. Time is abundant. The universe is nearly 14 billion years old. Our sun is middle-aged, just over 4.5 billion years old. But many stars in our galaxy are older. Planets have been forming around them for billions of years longer than Earth has existed. If life can emerge in a billion years, as it did here, then countless worlds have had time enough. If it takes longer, many still have had that time. The galaxy has been manufacturing habitable real estate for most of its history. Given all this, the universe should be crowded. If life arises readily under the right conditions, and if those conditions are common, and if time is available in abundance, then biology should be a typical feature of planetary evolution. Some fraction of those living worlds should develop complex organisms. Some fraction of those should develop intelligence. Some fraction of those should develop technology. Even if each step is rare, even if the odds are 1,000,000 to 1 at every threshold, the sheer number of planets makes intelligent, technological civilizations seem inevitable. And yet, silence. We've listened to the cosmos for over 60 years, scanning radio frequencies for signals that don't match natural sources. We've pointed our most sensitive receivers at nearby sun-like stars, at the galactic center, at the richest star fields. We've searched for pulses, for patterns, for narrow-band emissions that only a transmitter could produce. We've analyzed billions of radio channels simultaneously, filtering through the noise of pulsars and magnetars in the cosmic microwave background, searching for anything deliberate, anything structured, anything that suggests someone else is out there, trying to be heard. Nothing. No radio beacons, no interstellar broadcasts, no evidence of communication networks spanning star systems, no massive engineering projects visible at infrared wavelengths, no laser pulses flickering in the darkness. The galaxy hums with natural radiation, but beneath all that noise, we find no voice but our own. This is the Fermi paradox, named for the physicist who asked the obvious question over lunch one day in 1950. If intelligent life is common, where is everybody? The numbers suggest they should be here. The galaxy is ancient. A civilization only slightly older than ours could have spread through the entire Milky Way by now, even traveling at a fraction of light speed. There's been time enough for exploration, for colonization, for signals to cross and recross the galactic disk. Yet we see no trace. We detect no presence. The silence has weight. It presses against every assumption we make about life's inevitability. Perhaps life itself is the bottleneck. Perhaps the chemical leap from complex molecules to self-replicating systems is monumentally difficult. A stroke of luck so improbable that Earth might be the only place in the galaxy where it occurred. The origin of life remains deeply mysterious. We don't know how it happened here. We can't recreate it in laboratories. We have theories, hypotheses, plausible pathways, but no certainty. If the odds are astronomically low, then all those habitable worlds might remain sterile oceans and barren rock, waiting for a transition that never comes. Perhaps life arises easily, but dies young. Planetary environments are unstable. Asteroid impacts can sterilize surfaces. Stellar flares can strip away atmospheres. Nearby supernovae can bathe worlds in lethal radiation. Ice ages can freeze oceans, solid for millions of years. Runaway greenhouse effects can turn temperate climates into Venusian hells. The history of Earth includes multiple mass extinctions, moments when most species vanished, and the thread of biological continuity hung by chance. Maybe most living worlds never recover from their catastrophes. Maybe the default state is emergence followed by annihilation. Perhaps intelligence itself is rare. Life thrived on Earth for billions of years without producing anything like human cognition. Simple organisms dominated the planet for most of its history. Even after complex life emerged, intelligence took hundreds of millions of years to develop. It's not clear that evolution favors intelligence in general. It favors survival and reproduction. Intelligence is one strategy among many, and it's expensive. It requires large brains, long childhoods, complex social structures. Most successful species manage perfectly well without it. Perhaps Earth's path is an outlier, a contingent accident that rarely repeats. Perhaps technological civilizations destroy themselves. Nuclear weapons, climate collapse, engineered pandemics, artificial intelligence beyond our control. Every technology that grants power also grants the ability to cause irreversible harm. The gap between achieving radio communication and developing existential risks might be narrow, measured in decades or centuries. If self-destruction is likely, then the galaxy could be full of civilizations that briefly flicker into technological capability and then vanish, never surviving long enough to become detectable across interstellar distances. Perhaps they're hiding. Perhaps advanced civilizations recognize dangers we haven't imagined yet and choose silence as a survival strategy. Perhaps the universe is more hostile than it appears, filled with automated weapons or predatory intelligence that targets any species broadcasting its location. In such a cosmos, wisdom means invisibility. The quiet survivors listen but never speak. We hear nothing because anything noisy enough to be heard has already been eliminated. Perhaps they exist but don't care to communicate. Perhaps intelligence mature enough to cross interstellar space has moved beyond the desire for contact. Perhaps they've retreated into virtual realities of their own creation, finding more meaning in simulated universes than in exploring physical ones. Perhaps they've transcended in ways we can't conceptualize, leaving behind the concerns of flesh and matter and radio signals. We might be shouting into a forest where everyone has moved on. Perhaps the galaxy is simply too vast and we are too young. The nearest potentially habitable world might be dozens of light years away. A radio signal would take decades to arrive, decades more for a response. A civilization would need to transmit continuously for centuries to have any hope of being heard. They would need to aim their signals carefully, targeting specific stars, hoping someone is listening. We've only been capable of detecting such signals for a human lifetime. We've only been transmitting for slightly longer. In cosmic terms, we've barely begun to participate in whatever conversation might exist. Distance is its own kind of silence. The Milky Way is 100,000 light years across. Light itself, the fastest thing in the universe, takes 100,000 years to cross from one edge to the other. If a civilization on the far side of the galaxy began broadcasting the moment Earth formed, their signal is still halfway toward us, traveling through empty space, unheard. Time and distance conspire to isolate us. Even if the galaxy teems with intelligent life, even if thousands of civilizations exist right now, this moment, the overwhelming likelihood is that we are separated by gulfs too wide to cross in any meaningful time frame. We stand on a small world, third from an ordinary star, in an unremarkable region of a spiral galaxy that contains 400 billion stars. We've developed technology capable of detecting the faint shadows of distant planets. We've built telescopes that can analyze the chemical composition of alien atmospheres. We've launched spacecraft beyond the edge of our solar system. We've listened for signals and heard only cosmic background. The universe reveals itself slowly. Each generation of instruments shows us more. We can now detect planets around stars thousands of light years distant. We can measure the molecules in their atmospheres. Within the next decades, we may find biosignatures, chemical imbalances that suggest living processes. We may detect oxygen and methane in combinations that only biology produces. We may find our first real evidence that life exists elsewhere. But finding life and finding intelligence are different problems. Microbes don't build transmitters. Forests don't encode messages in radio waves. The universe might be thick with biology, still silent in the ways we're listening for. We exist in a moment of profound uncertainty. We know enough to understand how common planets are, but not enough to know how common life is. We know enough to calculate the age of the galaxy, but not enough to predict how long civilizations survive. We know enough to listen, but not enough to know whether anyone is speaking. The silence might be temporary, a product of our limited technology and short history of searching. The silence might be permanent, a fundamental feature of a universe where intelligence is vanishingly rare. The silence might be an illusion, broken by signals we haven't learned to recognize yet, by communication methods we haven't imagined. 6,000 confirmed worlds, and the number grows each year. Thousands more candidates await verification. Statistical models suggest planets around nearly every star. The galaxy is an archipelago of worlds, most of them unknown to us, many of them potentially habitable, some fraction possibly inhabited. We orbit one of those worlds. We've been here, in our current form, for a few 100,000 years. We've had technological civilization for a century or two. We are newcomers, still learning the rules, still discovering what questions to ask. The universe does not owe us answers. It does not owe us company. It simply is, vast and old and indifferent to our loneliness or our hope. Somewhere in the darkness, perhaps, another world harbors minds that wonder the same things we wonder. Perhaps they too have counted their neighboring stars and found them silent. Perhaps they too have built instruments to listen and heard nothing back. Perhaps we are two voices calling across an emptiness neither can cross. Or perhaps we call alone. The data accumulates, the searches continue. The telescopes stare into the night, counting worlds, measuring atmospheres, listening for patterns in the noise. And the universe, filled with planets, remains silent.